All right, this video is on multiplying and dividing with fractions. So we started on page 84, and we kind of went back to the area model or an array, and we saw how we can use an area model to model multiplying fractions. And we just did a quick reminder that multiplication almost always, if not always, means of. Alright, so basically when we're finding 1/4 times 1/2, we're finding 1/4 of 1/2. Alright, I think that's helpful to remember. So what do? Well, first we find what's 1/4 look like. So if this is our box, we broke it into fourths, and then this bar right here in blue would be our 1/4 piece. Okay, and then we broke our box into halves, and we shaded in 1/2, so that would be this side in red. And we look at how much of this has blue and red together. All right, well, there's one box here out of 1, 2, 3, 4, 5, 6, 7, 8. There's only one that has both colors out of the 8. So our answer would be 1/8. All right? And so this example down here was another opportunity to practice it. All right? We did 2/3, that's in green, and then 3/4, which is in black, and then we looked at there's 1, 2, 3, 4, 5, 6 out of our 12 altogether boxes. So 6/12 is our final answer. All right, and then of course we could simplify it to 1/2. Then we're talking about a pattern. We notice basically in both of these situations, if we multiply the top numbers, the numerators, and multiply the bottom numbers, or the denominators, we would get our answer. So again, 2 times 3 would be 6, and 3 times 4 is 12. So multiply the numerators, multiply the denominators, and then simplify if possible, like we did here on number 2. Okay, but what if it's not just straightforward fraction? What if it's a mixed number? Well, we looked on page 86 at this example, and we talked about the steps. She went from a mixed number to an improper fraction, still multiplied across the top, and then simplified, and then turned it back to a mixed number. In case you forgot how to do that, you can take 3 times 3, I'm looking at this mixed number, and take the the denominator times the whole number, and add the numerator, you get 11/3. All right, and that's what they had right here. And same thing here, 4 times 2 would be 8, plus 1 would be 9/4. And then multiply across the top. And then when we get to this, 33/4, we simply divide the numerator, 33, by 4. So that's what I have shown over here. 4 goes into 33 8 times with one remainder, 1/4. All right, so you turn it back to a mixed number. So again, change to improper fractions, multiply across the top and across the bottom, and simplify and change to a mixed number. All right. Then we looked at division. And to start off, we looked at a model. This is on page 88. We looked at a model of whole numbers. If I take 12 divided by 3, basically means I take 12 things and I group them into groups of 3. How many groups do I have? Well, I would have 4. Or if I looked at a number line, I have 12, and I break it into groups of 3, I have 4 groups. All right? Then if we turn that into fractions, I have 2 physical models, these circles, and then I break each circle into halves. How many halves do I have? No pun intended there. I have 4. All right, with the line model, I count by halves. How many halves will fit in the 2 whole? Well, 4 will. All right, so 2 divided by 1/2 equals 4. All right, and then turn you loose on solving a few of these. We have 4 groups, and I divide them into halves. So I have 8 groups, sorry. And then the same thing, I had 4 cups breaking into quarter servings. I've got 16. And if I have 4 cups and break them into thirds, I have 12. All right? So we're supposed to look for a pattern. Some of you pointed out that if I take the bottom number here, for example, this 3, and I multiply it by this whole number, I get the 12. Same thing here. 4 times 4 would be 16. And then 2 times 4 would be 8. Okay, what's another pattern? Well, if we take this first number and we turn it into a fraction by putting it over 1, and divide it by a half, what I could do is turn this division into multiplication and then flip this. So now it's 4 over 1 times 2 over 1, which is 8 over 1, but 8 over 1 is the same as 8. Okay, so this is going to be really handy on our assignment. All right, so let's take a look down here on our assignment. Notice we're multiplying two mixed numbers, so you'll probably want to look at that previous page we looked at. Oops, went too far. This one right here on 86. Oops. And then on this one, we'll probably want to use that device, or that method that we just looked at over here, where we turn the first number into a fraction and we change division to multiplication and then turn this upside down. So the numerator, or the denominator becomes the numerator, numerator becomes the denominator, and then we multiply. All right, so got these 4 problems. Hopefully they do well, go well for you. Again, thanks for watching.